Hello and welcome to my channel. In this video we are going to solve a question from differentiation which had appeared in Cambridge 9709 Pure Mathematics 1 February-March 2025 paper. Now this question has two sub-questions. So let us start with the first question now. The diagram shows the curve with equation y is equal to 2x square minus 5 over x plus 3. The curve crosses the x-axis at the point P 1, 0 and M is a minimum point. Find the gradient of the curve at point P. So here we have been given an equation of a curve and its graph has also been given, and it is mentioned that the curve crosses the x-axis at point P. So the coordinates of point P are given to us as 1, 0 and M is being mentioned as a minimum point because we can see that this part of the curve is taking a downward turn. So this becomes a minimum point. Now we have to find out the gradient of the curve at point P. Now remember that to find out the gradient of the curve, we have to differentiate y with respect to x. So before that, let us write down the equation of the given curve. So here we have written y is equal to 2x square minus 5. Now this x is in the denominator. So I have taken x to the numerator. So this positive power 1 now becomes a negative power, that is 5x to the power of negative 1. So we can do this by using the laws of indices plus 3. Now to differentiate this with respect to x, we are going to use the power rule of differentiation, which is given as dx to the power of n over dx. So any function which is of the form x to the power of n can be differentiated as, now the power comes down, that is n times it gets multiplied with x, and the power of x reduces by 1. So using this formula, we have written the gradient, which is dy by dx, is equal to, now this 2 is written as it is, now the power 2 comes down and gets multiplied with this 2, times x to the power of, now the power of x reduces by 1, giving us 1, minus, now this 5 stays the same, now this power negative 1 comes down and gets multiplied with 5, times, now x power reduces by 1, so minus 1 and minus 1 gives us minus 2. And remember that the differentiation of a constant like 3, 5, 100 and so on will be 0. So we have not written anything for 3, it will be 0. So simplifying this, we get 2 times x is 4x. Now minus times minus is plus, so 5 times x to the power of negative 2. Now if you want to keep it this way, you can keep it, or you can change the power of x to a positive power. So for that we have to send x to the denominator. So here we have rewritten dy by dx as 4x plus 5 stays in the numerator, and x to the power of negative 2 goes to the denominator and becomes x to the power of positive 2. Now once we have got the gradient, we have to find out the gradient of the curve at point P. And since we have been given the coordinates of point P as 1, 0, we have to just plug in the value of x as 1 in dy by dx and get its value. So here we have written at point P 1, 0, the x value is 1. So now dy by dx will be equal to 4 times 1 plus 5 over 1 square. Now simplifying this, we get 4 times 1 is 4 plus 5 over 1 square gives us 5. So dy by dx will be equal to 4 plus 5, which is 9. So this is our answer to part A of this question. Now let us move on to the part B. Find the coordinates of M. Give each coordinate correct to 3 significant figures. Now here in the graph, we had been given the coordinates of point P as 1, 0. Now in this question, we have to find out what are the coordinates of point M. And in the question, it was mentioned that M is a minimum point. And remember that to find out the minimum point or maximum point, we have to consider the gradient and equate it equal to 0. And minimum and maximum points are also the turning points or the stationary points. So the condition for finding stationary points is equate dy by dx equal to 0. Now we had got the gradient dy by dx as 4x plus 5 over x square. So we are going to equate this equal to 0. Now over here, let us try to get a common denominator. So 4x can be written as 4x over 1. So we are going to multiply this x square with 4x over here in the numerator and x square gets multiplied in the denominator as well. That is 1 times x square. So here we get 4x multiplies with x square, giving us 4x cube plus 5 over a common denominator, that is x square, equal to 0. Now this denominator multiplies with 0. Now let us take positive 5 on the other side of equal to sign. So we get 4x cube is equal to negative 5. Now dividing both the sides by 4, we get x cube is equal to negative 5 over 4. Now taking cube on the other side of equal to sign, we get x is equal to cube root of negative 5 over 4. So let us see what value this gives us. So this is going to give us the value as negative 1.0772. Now since we have been asked to get the coordinates to 3 significant figures, we are going to round this number as negative 1.08. So here we have written x is equal to negative 1.08. Now we have got the x coordinate of m. We need to find out the y coordinate. So let us consider the y equation which was given to us. That is y is equal to 2x square minus 5x to the power of negative 1 plus 3. You can take the original equation as well where x was in the denominator. Now here we are going to just plug in the value of x in this equation. So we are going to get y is equal to 2 times negative 1.08 square minus 5 times negative 1.08 to the power of negative 1 plus 3. So let us see what value this gives us. So this gives us the value of y as 9.962. Again rounding it to 3 significant figures, we get the value of y as 9.96. So here we have written y is equal to 9.96. So these are the coordinates of the point M, which is a minimum point. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out this video on binomial expansion, where I have covered 4 questions from February, March and May, June 2025. And if you are liking my videos, like, share and subscribe to my channel. And thank you for watching.